In 1867, a Russian chemist named Dmitry Mendeleev began gathering physical and chemical properties of known elements. Some of these properties include the atomic mass, the color, the density, the melting point, and what each element did or did not react with. Mendeleev made up a card for each element, listing everything he knew about them, and sorted the cards based on similarities in the element's properties. A complete pattern emerged when he placed the elements into vertical columns and horizontal rows in order of increasing atomic mass. The properties of the elements repeated in a pattern or in a periodic fashion. Hence the name, the periodic table of elements. Mendeleev left spaces for elements that were yet to be discovered or synthesized. The modern periodic table, with the discovery of the proton, today's periodic table is arranged in rows and columns where elements are listed from left to right and top to bottom according to their increasing atomic number. The rows of a periodic table are called the periods. There are 7 periods on the periodic table. Elements within a period show gradual changes in properties. As you go from left to right within a row, the atomic number increases and the elements gradually change from metallic to non-metallic, and they finally go to noble gases at the very far right of the periodic table. The columns of a periodic table are called families or groups. There are 18 families on the periodic table. Elements in the same chemical family share similar physical and chemical properties. Let's practice identifying elements given the position of period and group on a periodic table. What we want to find is the element that corresponds to period 4, group 5. So let's pull out our periodic table. So we are going to look for period 4, group 5, and our element is vanadium. Next, let's try group 12, period 5. Group 12, period 5. If we follow these, we will see that the element we are looking for is cadmium. Let's find period 6, group 1. Group 1, period 6. This is our element. We are looking at cesium. Finally, we'll look for group 18, period 1. Group 18, period 1, we are looking at helium. All elements can be described as metals, nonmetals, or metalloids. These are groups of elements that share certain properties. Let's first take a look at the metals. Metals all share metallic properties. They're all solid at room temperature, except for mercury, which is a metal that is a liquid at room temperature. All metals have high luster or are shiny. All metals are good conductors of heat and electricity. All metals are malleable. We can hammer them into sheets. Metals are also ductile. They can be stretched into wires. Examples of metals include silver and iron. Next, we're going to look at what makes a nonmetal. Nonmetals have characteristics or properties which we call nonmetallic properties, and they're often the opposite of the properties we saw for the metals above. These appear on the right side of the periodic table. Only 17 elements are nonmetals. Of those, 11 are gases, 5 are solids, and 1 is a liquid. Bromine is the one that's a liquid at room temperature. They are not shiny, they are dull or have low luster. They are poor conductors of heat and electricity. We say that they are insulators. They cannot be hammered into sheets. They are not malleable. They cannot be pulled into wires. They are not ductile. As you can see, these properties are opposite to those properties of metals. Examples of nonmetals include sulfur and chlorine. Now, there are a group of metals that share properties of both metals and nonmetals. These elements are called metalloids or semimetals. They are found on the periodic table between the nonmetals and the metals. I'm going to color these in, or highlight them rather, in green. And you'll see why in a moment. So as I mentioned, they have some metallic properties and some non-metallic properties. They conduct electricity, but not very well. They're considered semiconductors. A very common example of a metalloid is silicon. You're going to use the periodic table that I've provided to show me which elements are metals, and you're going to color those in blue. Which elements are nonmetals, and you're going to color those in yellow. And which elements are metalloids, and you're going to color those in green. Your periodic table, when you're done, will look like this one. This periodic table shows that the majority of the elements colored in blue are metals. And they're located at the left-hand side of the periodic table. If you go to the right-hand side of the periodic table, you'll notice that the elements colored in yellow are nonmetals. There are 17 of them. Now, where the metals and nonmetals meet up, there are a special group of elements that share the properties of both metals and nonmetals and are called metalloids. You can take a screenshot of this periodic table or Google a periodic table with metals, nonmetals, and metalloids, and color them in using the scale or the legend that we provided.